when we add or subtract two fractions, the denominators have to be the same. Because if they're the same, we add or subtract the numerators depending on whether we're adding or subtracting between the two terms, addition or subtractions between the two terms. So if we look at the first one, 7 over 4x plus 3 over 4x. The denominators are both what? They're the same. They're both 4x, which means we can make it into a single fraction with the numerators being added because the sign between the two of them is addition. Sydney? That way you don't have to knock. Now, we don't necessarily need the parentheses because when we're adding two terms, we're not having to worry about signs changing or having to distribute a negative. It's really just 7 plus 3. And 7 plus 3 is 10. Now, before we say we're done, we do need to make sure nothing simplifies. And just like multiplication, we want to make sure we factor the top and bottom of the fraction as far as possible, simplify like terms. The top of this fraction is 10. It is one term. There's no way to factor it. It is simplified as possible. The bottom is 4x. Again, it is one term. It is factored. Do we have any addition or subtraction left on top? Do we have any plus or minus? Nope. On the bottom, do we have any plus or minus signs? No. And because we're having just a product, we can simplify the 10 over 4 because they both have a common factor of 2. We don't have to write this, but we could say that it's 2 times 5 over 2 times 2x. Because our 2 over 2 will simplify to 1, leaving us with what? 5 over 2x. And this works because we can rewrite the top and bottom as a product, as multiplication with that 2 over 2, giving us 2 over 2 times 5 over 2x. 2 over 2 reduces to 1, simplifies to 1, leaving us with our 5 over 2x. Questions on this here? So the reason this works well is because it was a product. And just put them. Questions on A before we look at B. We're ready to look at B. We have 2x over x plus 6 minus 5 over x plus 6. The denominators are the same. Which in this case means we can subtract the numerators. We can subtract our numerator terms because there's a subtraction in the middle. Now at this point here, we can simplify those parentheses. We still have x plus 6 on bottom. But on top, we have 2x minus 5, yes? Questions on how we got to this point here? Are 2x and 5 like terms? No. 2x and 5 are not like terms, so I can't actually subtract 2x and 5. Is there a common factor between 2x and 5? Can we factor it further? No, 2 and 5 don't have a like term. 2x does have an x, but 5 does not have an x. So that's as simplified as it gets, yes? Let's look to the bottom, x plus 6. Is there a greatest common factor between x and 6? No, not x and 6, because we do have an x on top, yes? So nothing we can do factoring-wise to simplify further. At least the numerator itself and the denominator, the top and bottom independently of each other. Is there addition or subtraction left on top? Yes, because we're saying, what, 2x minus... And because there's subtraction on top, it's telling me that the 2x and 5 are a expression. They're stuck together. I can't just rip one part of that expression out. They are stuck together. It also means on bottom, the x plus 6 are stuck together. As much as I want to cross out or simplify the x from 2x and the x on bottom, we can't because that x is stuck with the 2x minus 5. And on bottom, we have the x plus 6. Those are locked together. So if we look at the top and bottom, is there anything in common? Well, the x, but they cannot cross out because the 2x is minus 5 is stuck together. Yep, nope, this is as far as it goes. Because we can simplify with products, multiplication, because 2 and x are being multiplied together, but because we're subtracting 5 from it, that's one term, we can't just remove the x. So we kind of see the difference between A and B. Let's look at 1 and 2 next. Number 1, we have 8/12 minus 5/12. Yes, 8/12 does have a common factor on top and bottom, but are the denominators the same? Well, 12x and. So if I reduced the first one, that 8/12, the denominators would not be the same anymore, so we couldn't subtract. Try to focus, and we try to do simplifying, reducing, removing like terms on top and bottom. We save it towards the end or till we're almost at the end. Because the only way we can subtract these two fractions, these two rational expressions, is if the denominators are the same. And if we reduce the 8/12 to 2/3, the denominators would not be the same anymore. We could not subtract. Now, we don't need the parentheses on top. We use them just to make sure that we distribute our negatives, we apply everything properly. Eight and 5, are they like terms? 8 minus 5 is? So we had 3/12x, yes? 3 is a single term on top. We can't factor the numerator any further. 12x, one term, yes? Do we have any addition on top or bottom or subtraction? Two terms being subtracted, two things being added? No, so there's nothing restricting me from simplifying the 3/12. Because what's in common with 3 and 12? What can divide into both 3 and 12? 3. And if I factor that 3, or if I simplify that 3 out, I remove or divide the top by 3, we get 12 divided by 3 is, and we still have our x. Because 3/12 is 1/4x. 3/12x is 1/4x. And the big difference between this one and the last one is the 12x on bottom, the 12 and x are being what? Multiplied. They're not being added. When I have multiplication, we can do this simplifying. When the terms are being multiplied together, we can split them apart, simplify down. I cannot do that with addition. I cannot do that with subtraction. They are the whole term. The whole terms have to be the same for it to be able to reduce. Questions on number 1, and it being 1/4x. We ready to look at number 2?
Yeah.
2/3x squared plus 1/3x squared. Well, the denominators are the same. They're both what? 3x squared. Since the denominators are the same, we can add or subtract the numerators. Here, we're adding 2 and 1, and we're putting it over the denominator, which is 3x squared. And just like the last few, we really don't need the parentheses. This is really just 2 plus 1. And what is 2 plus 1? 3. Telling us that we have 3/3x squared. Now the number of terms on top is 1, the number of terms on bottom is. And the reason I point that out is because that means factoring-wise, there's no greatest common factor. We can't use any of our factoring properties. They are simplified as it is. Now we do see that there's a 3 on top and bottom, yes? So those will simplify as long as I don't have addition or subtraction messing that up. Because on bottom, the 3 and x squared, are they being added, subtracted, multiplied, divided? Multiplied, yes? So multiplication is fine because that 3 on top and bottom, we can simplify it because the 3 and x squared on bottom are being multiplied. Because really what we're doing to simplify this is I'm splitting it up into 2 separate fractions. Because 3 times x squared, top with top, bottom with bottom. So 3 times 1 on top is 3. That is the same expression, yes? On bottom, 3 times x squared is, yes? That's 3 divided by 3. 1 times our 1 over x squared is 1 over x squared. And we can do this because of multiplication. When we add or subtract 2 fractions, the denominators have to be the same. So if what's on top is being added, we can't just cross it out because it would just be 2 over the denominator plus the other term over the same denominator. They don't simplify out. I can't manipulate it like this here. Because if I split it up with addition, both denominators would have to be 3x squared. They'd have to be the same. I can't write 1 as 3 and 1 as x squared. That's the nice thing with multiplication. I can split the terms apart, simplify where needed. Questions on 1 and 2? Let's look at 3 and 4. Four x over x minus 2 minus x over x minus 2. Are the denominators the same? Yes. Well, so if I subtracted, we get 4x in parentheses minus x in parentheses. Well, again, the distributing the negative is just going to apply to the x, telling us that we have 4x minus x over x minus 2. Questions on this first main step? Well, what is 4x minus x? Like terms, so we can subtract, yes? The numerator is a single term, 3x, so we can't factor, be a greatest common factor, choose all of our factoring methods. On bottom, we do have 2 terms, x and 2. So we would check greatest common factor, x and 2. X does not have a number, 2 does not have a variable. Degree is 1, that's as simplified as it gets, yes? Now, if we do notice here, there is an x on top and an x on bottom, yes? And as long as one of those 2 does not have addition and subtraction between it, we can cross it out. But the x on bottom is being subtracted from 2. We have x minus 2. 2 is being subtracted from x. So x minus 2 is a whole term. It is one term. They're stuck together. I can't just take the x away. It will make it a different expression, a different term. So there's no way to simplify that x on top with that x on bottom, because the x on bottom is stuck with the 2. They're stuck together. Now, it doesn't have it, but if it did have a greatest common factor of x and we pulled it out, I have x times that x minus 2, yes? We do have a product. That x that's being multiplied out front can be simplified with the top because the x and x minus 2 are being what? Multiplied. We can simplify with multiplication. We cannot simplify just with this addition or subtraction. We see the difference between those 2. Okay. which means our final answer is 3x over x minus 2. Be ready for the next one. 2x squared over x squared plus 1 plus 2 over x squared plus 1. Are the denominators the same? Yes, they're both what? They're both x squared plus 1, which means since the denominators are the same, we can add our numerators together. Now, we don't necessarily need the parentheses for this here. As we distribute the plus, we distribute our signs. Really telling us that we have 2x squared plus 2. 2x squared and 2, are they like terms? No. I can't add those. Well, we do have x squared on top and bottom, yes? But on bottom, we have x squared plus 1. Those two terms are stuck together. The 2x squared plus 2, we have addition on top, so those two terms are stuck together, yes? So we can't just simplify there, but let's just make sure nothing simplifies or factors. 2x squared plus 2. Is there a greatest common factor between those two terms? Because 2x squared plus 2 does have a greatest common factor of 2 that we can factor out, yes? And what happens when we factor a 2 out of 2x squared? We get x squared. Plus, if I factor 2 out of 2, 2 divided by 2 is? And x squared on bottom is one term, yes? Do we have something in common on top and bottom? X squared plus 1, yes? Is the 2 on top and the x squared plus 1 being added together? No, they're being what? Multiplied. So can I simplify the x squared plus 1 on top with the x squared plus 1 on bottom? Yeah, because they're being what on top? Multiplied. These two will cancel, leaving me with 2 over 1, or just 2. Yeah, both are the same. Now, if that 2 on top and the x squared plus 1, if we'd had, say, 2 plus, we couldn't do it because the 2 and that whole expression are stuck together with that addition. Yeah, then we would drop the parentheses and add it and get x squared plus 3. But because they're being multiplied, really I can think of it as 2 over 1 times x squared plus 1 over x squared plus 1. The x squared plus 1s would simplify to 1, giving us just 2. So we kind of seen the difference between two terms being added and multiplied. Multiplied makes simplifying nicer. But if it's just addition, subtraction, like on the last one, we can't just cross the x's out because they're stuck together. Questions on this here? Now, the big thing with this here is adding or subtracting unlike denominators, because there's going to be more that don't have like denominators than there are that will. And if the denominators are not the same, we have to get them to be the same. And we need to find the first expression or first number that would make them be the same, and that's called the least common multiple. Now, hopefully at this point you talked about common multiples at some point. Multiples of a number, the same number. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We can keep going on. If we look at the 3 they listed here, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96, 104. I don't know why I wanted 114. 104. 112, 120, 128, and it keeps going on, yes? So this is one method. Now, these are all multiples of 8, yes? And if we look for a common multiple, we're looking for one of the multiples that's the same for two numbers, yes? Yeah, there's going to be more than one. But could it be possible that the least common multiple, the first number that 8, 14, and 16 is not listed here? I mean, it could. There's no guarantee that it's in these. But this is one way to find it. Because I could do the same thing for 14. And if you don't want to write this, you don't have to. Because it'd be 14, 28, 42, 56, 70, 84, 98, 112, 126, 140, 156. I'm already tired of writing 14s. So we get these here, yes? And just with these two numbers, common multiple, well, 56 is a common multiple, yes? We also have 112. And if we kept the numbers going far enough, we would find another common multiple eventually, yes? Now, when we talk about least common multiple, we're really saying what is the first multiple that both numbers have, that they have in common. So for 8 and 14, the least common multiple is 56, which is fine. But does that necessarily mean 16 is also 56? No. So we'd have to do the same with 16. I do not want the calligraphy pen. 16, 32, 48, 64, 80, 96, 112. So the least common multiple between these three numbers is 112. But it's not necessarily guaranteed that we find it for 16 in the first 7 factors. But if you notice, especially 8, we had to go way far out there to find it. This works. It is a way to find least common multiple, but I wouldn't necessarily call it the most efficient way to find it. To find least common multiple, one of the main ways to find it is looking at the factors of each number, the prime factors of each number. What numbers multiply together to give us 8, 14, and 16. So to do this here, let's look at 8 first. What two numbers multiply together to give us 8? So we're going to start with 2 and 4. 1 and 8 don't tell us a whole lot because we want to look at prime numbers, and 1 isn't prime. 1 is not a prime number. So 2 times 4 is, well, 4 is what? 2 times 2. So the prime factorization for 8 is 2 times 2 times 2. We're only looking at the prime number. So the composite number 4, we don't care about because 4 is 2 times 2. 2 times 2 is 4 times 2 is 8. So 8 is 2 times itself 3 times. Let's look at 14. What prime number goes into 14? 2. And it'd be 2 times 7, yes? 2 is prime. 7 is prime, yes? So actually the prime factorization of 14 is just 2 times 7, yes? Let's look at our last number, 16. I always start with 2. to be what? 2 times 8. Now, if 2 didn't work, I go to 3, 5, 7. We work our way up the primes. Now, 8, we already said is 2 times 4, and 4 is 2 times 2. How many 2's do we have? So 8, 2 times 2 times 2 times 2. Questions on this here? I don't know if y'all have seen this way. Probably it's been a minute. Now, the least common multiple is going to have the most factors of each factor. So when we look at the three numbers, 8, 16, 8, 14, and 16, we're looking at the numbers that multiply together to give us those numbers, not the number itself, or the composite numbers. Now, it doesn't matter which order we look at the numbers. We can look at 2's first. And we take the number of 2's that's equal to the most 2's in any of the three factors, or sets of factors. So 8 has how many 2's? 3, yes? 14 has how many 2's? 1. And 16 has how many? So which one has the most 2's? So it has 4, it has the most, yes? So how many 2's would we take for the least common multiple? 4. We take the number 2 equal to whichever one has the most. Now 8 has 3 of them, that's fine, but because 16 has 4, we need 4 of them in the least common multiple. Questions on that there? Does 8 have any other numbers as factors other than 2? Well, no, 16 only has 2's. 14 has what? 7, yes? And it shows up how many times? 1. Doesn't show up anywhere else. So we need it at least once. Since it showed up in 1, we need it at least once. Even if it showed up once in 2 of them, it only shows up in 1 time in either one. So the most that 7 shows up as a factor of any of the numbers is once. Now at this point here, we can just multiply these together. We can grab a calculator, say 2 times 2 times 2 times 2 times 7. And we would see what the least common multiple is. Well, 2 times 2 is 4. 2 times 2 is 4 times 7. 4 times 4 is 16, and 16 times 7 is 112. Well, that's what we found by the other method, yes? I think this is a little nicer because we're not having to list out 14 factors of 8 to get there. Questions on this here? Interestingly enough, it actually also tells us what we need to multiply each of those numbers by to get it to be the least common multiple. 8 has how many 2's? How many does the least common multiple have? 4, yes? How many 2's is it missing? 1. And it's also missing a 7 as a factor, yes? So this is kind of interesting. Figure that out. Because we said 8 was missing a factor of 2 and a factor of 7. 8 times 2 times 7 is 112. 14, our middle number. It had 1, 2, and it had 1, 7. So it has the 7, but the least common multiple does. It has 1, 2 that it has, but it's missing what? 3 factors of 2, yes? So if I take 14 and multiply it by 2 3 times, we get. And 16 had 2 4 times. What factor is it missing? The 7, yes? 16 times 7 is? It's all about the factors. So the least common multiple is 112. Either way works. Listing out all the multiples works, but also listing out the factors I think is a little bit faster. Yes? Questions? Are you ready to see another one? Nine, 12, 15. So let's look at the prime factorization of 9 first. What multiplies together, other than 1, that gives us 9? 3 times 3. 3 and 3 are both prime, so we just say the prime factorization is 3 times 3, or 3 squared. Our next number is 4 times 3, 3 times 4 is 12, yes? 3 is prime, is 4 prime. What's 4? 2 times 2. So we have 2 times 2 times 3. Now the way you write it really doesn't matter. I write it from smallest to larger numbers. 2 times 2 times 3. Questions on the factored forms of 9 and 12? Now we need to look at 15. What are 2 numbers besides 1? 3 times 5, yes? Three and 5 are prime, so that's as far as that goes. Least common multiple. Doesn't matter where you start with the factors, which one you want to pick first or look at first. I always start with the smallest and work my way up. So when I look at all these here, well, 2 is the smallest factor that shows up in any one of them, yes? How many factors of 2, or how many times does 2 show up as a factor for 9? 0. Yeah, I started with 9 instead of 12. 0. 12, 2 shows up twice. And how many times does 2 show up as a factor for 15? 0. So with 12, it shows up the most with 2 2's, yes? So how many times does 2 need to show up as our factor for least common multiple? Twice. So we have twice. Now 3 shows up in all 3, yes? With 9, how many times do we have 3? 2. 3 times 3, we have 2 of them, yes? With 12, how many do we have? 1. With 15, how many do we have? So how many 3's do we need? 2. Yes, there's 4 across all of them, but we want the number of 3's equal to whichever one has the most 3's. Not combined, but since 9 has 2 of them, and that's the most 3's that show up as a factor, in each one, we need it twice. Questions on that there? It's fine that 9 has it, or 15 has it once, and 12 has it once, but because 9 had 2, we need 2 towards the total. Are there any other factors we need to look at? 5. 15 has it, 12 has it, 0, and 9 has it. So how many times do we need it listed? So the factored form of the least common multiple for this is 2 times 2 times 3 times 3 times 5. Now we can do that by hand. I can say 2 times 2 times 3 times 3 times 5 is. So the least common multiple is 180. Questions on this here? We'll stop here.